Welcome, learners. Today, we are going to dive into the world of Solidity, a programming language used for creating smart contracts on the Ethereum blockchain. Solidity was created by Ethereum, the second largest cryptocurrency market by capitalization. It was released in 2015 and is led by Christian Reitweisner. Let's look at some key features of Solidity. It is a high-level programming language specifically designed for implementing smart contracts. This means Solidity is a programming language that focuses on creating smart contracts which are self-executing contracts with predefined rules and conditions. It provides a user-friendly and expressive syntax that allows developers to write a code for these contracts in a straightforward manner. The second key feature is Solidity is a statically typed object-oriented language, which means it focuses on contracts and their interactions. Being statically typed means that Solidity requires explicit type declaration for variables and function parameters, which enhances the reliability and security of the code. Additionally, Solidity follows an object-oriented programming paradigm, this allowing developers to define objects with associated properties and functions also, making it easier to organize and manage complex smart contracts. The third one here, it draws inspiration from popular programming languages like Python, C++, and JavaScript. So Solidity takes inspiration from well-established programming languages, incorporating familiar syntax and features. This makes it easier for developers who are already familiar with Python, C++, or JavaScript to transition to Solidity and leverage their existing knowledge and experience. So Solidity code also run on Ethereum virtual machine, okay, which is a runtime environment. We will see it after a few minutes. Runtime environment specifically designed to execute smart contracts on the Ethereum blockchain. So Solidity code is compiled into bytecode that can be executed in Ethereum virtual machine, ensuring the deterministic and secure execution of smart contracts across the Ethereum network. Also, Solidity support complex user-defined programming libraries and inheritance. So Solidity provides powerful features for developers to define complex logic and structures within their smart contracts. It supports user-defined data structures, functions, and libraries, allowing developers to create reusable code components. Also supports inheritance, enabling code reuse and modularity by allowing contracts to inherit properties and functions from other contracts. Solidity is the primary language used for building a blockchain running platform. So it has become the de facto standard for developing smart contracts on the Ethereum blockchain. It was widely adopted by developers and is the primary language used for building decentralized applications and a blockchain running platform on the Ethereum. With Solidity, you can create various types of contracts such as voting system, blind auctions, crowdfunding platforms, and multi-signature wallets. So Solidity provides developer with the flexibility to create a wide range of smart contracts. These contracts also can serve various purposes. As I said, voting system to facilitate democratic decision-making, blind auctions for fair and transparent bidding processes, crowdfunding platforms for raising funds, and multi-signature wallets to enhance security in managing digital assets. So Solidity features and capabilities make it a powerful tool for developers to implement complex and secure smart contracts on the Ethereum blockchain, enabling the creation of innovative decentralized applications and services. Now let's talk about the Ethereum. Ethereum is a decentralized open source platform that operates on the blockchain. It is widely used to run smart contracts, which are applications that execute programs without the possibility of fraud, interference from a third party, censorship, or downtime also, okay? What about the Ethereum virtual machine? As we mentioned previously, Ethereum is virtual machine is an essential component Ethereum. It provides a secure runtime environment for executing the smart contracts. It focuses on security and executing untrusted code using a network of public nodes. Also, it ensures that programs don't have access to each other's state, and also ensures the communication without interference. Additionally, the Ethereum virtual machine prevents the denial of service attacks. So now we will talk about the smart contracts. Smart contracts also high-level program codes compiled into Ethereum virtual machine bytecode and developed to Ethereum blockchain for execution. They allow for credible transactions without the need for intermediaries, and these transactions are trackable and irreversible. Okay, now look at this example. It's actually a sample Solidity program to demonstrate how to write a smart contract in Solidity. Let's talk about this example line by line and explain it. The first line about Pragma Solidity, this is a version Pragma. It's instructions to the compiler on how to create the code. All Solidity source code should start with a version Pragma, which is a declaration of the version of the Solidity compiler this code should use, okay? This helps the code from being incompatible with the future versions of the compiler, which may bring changes, actually. Okay, the code states here that it's compatible with compiler of the version greater than and equal to 0.4.16, but less than version 0.9.0. The next instruction is contract keyword here, contract test. We have here functions and data. So the contract keyword declares a contract under which is the code encapsulated. Okay. Now look at the state variables. Here we have uint public, var1, var2, var3. This is state variables are permanently stored in contract storage that they are written in Ethereum blockchain. So this line mean uint means unsigned integer of 256 bits. So this is declares a state variable called var1 of type uint. Okay, think of it as adding a slot in a database. Okay. Similarly goes with the declaration of var2 and sum. Then here we have a function set, function declaration, function set uint x and uint y, public function get, public, here we have the public function get. Also, this is a function named set of access modifier type public, which takes a variable x and variable y data type uint as a parameter. This was an example of a simple smart contract that updates the value of var1 and var2. Anyone can call a function set and overwrite the value of var1 and var2, which is stored in the Ethereum blockchain. This is an example of a decentralized application that is a censorship proof of unaffected to the shutdown of any centralized server. As long as someone is running a single node of the Ethereum blockchain, this smart contract will be accessible. The variable sum here calculated by adding the values of variable var1 and var2. Function get will retrieve and print the value of the state variable sum. Okay, now let's explore how to execute Solidity smart contracts, how to execute that code. There are two ways to execute Solidity smart contracts, offline mode and online mode here. About the offline mode, we need to follow several steps, including downloading and installing Node.js, setting up a development network, installing Truffle and Ganache CLI, creating and deploying smart contracts, interacting with them from Truffle console, and writing tests to ensure the Solidity code's functionality. In online mode, we can use Remix IDE to compile and run Solidity smart contracts. It provides a user-friendly interface for executing and debugging contracts. So to execute Solidity smart contracts using Remix, we need at the first, open the IDE in a browser, create a new file and write the contract code and compile it, deploy the contract and run the transactions. The IDE also offers debugging capabilities to help us identify and fix any issues in our code. So let's see this environment at the beginning. We will talk about navigating the Remix IDE interface. Okay. Remix IDE actually is an integral part of the Ethereum blockchain development landscape, offering a browser-based platform for the creation, testing, and deployment smart contract. It's essentially a gateway that simplifies the complexities involved in blockchain development, particularly catering to those working on the Ethereum network. So the core of Remix IDE, it's user-friendly interface accessible directly through a web browser. IDE means Integrated Development Environment, is a comprehensive and user-centric tool designed for developing smart contracts, particularly in Solidity, which is a programming language for Ethereum blockchain. The interface here of Remix is laid out to facilitate ease of use and efficiency in the development process. Let's explore the key component here of the interface. As you see here, we have a file explorer panel. This is the organizational hub of your project. It's where you manage your project's files and directories. You can perform various operations like creating a new file, okay, or creating a new folder to arrange your files. You can importing existing files and arranging your project's structure in a systematic way. This panel makes it easy to navigate through your files, providing a clear view of your project's hierarchy and structure. Now, if we choose this option, Start Coding, we have here a code editor panel. This is the heart of Remix IDE. This panel is where you write and edit your Solidity code. The code editor is equipped with features that are essential for a smooth coding experience. such as a syntax highlighting, which helps in distinguishing elements of the code through color coding, and code completion, which aids in writing code more efficiently by predicting and suggesting completion for partially type strings. These features actually enhance readability and reduce the likelihood of errors, making the coding process more efficient and less error prone also. About the compile type, here we have a compile button. Okay, this is the compile type. This component is crucial for validating your code. Once you have written or edited your code in the editor panel, you need to compile it. Okay, compiling the code checks the error or checks for errors and ensures that is syntactically correct and ready for deployment on the blockchain. Okay, so it's crucial for validating your code. Remix IDE compiler is a robust, providing detailed feedback on your code. It highlights errors, points out potential issues also, offers a suggestion for improvement. This not only helps in fixing immediate issues, but also contributes to learning and improving your coding skills over time. Okay, here we have about the deployment and run transactions. Deployment options. Remix allows developers to deploy smart contracts on different Ethereum network here. And different Ethereum networks, including both testnets for testing, and this is the testnet for and mainnet for final deployment. This is crucial because it navigates what it gives developers the flexibility to test their contracts under conditions that closely mimic the actual environment in which the contract will operate. So by using testnets, developers can simulate real-world user interactions without incurring the costs associated with the main nets. Okay, about the gas gas analysis. In the Ethereum network, every transaction and the smart contract execution requires a gas, and the cost of gas can vary significantly. Okay, efficient gas usage is crucial for the practicality and financial viability of a smart contract. So Remix IDE addresses this by providing detailed gas analysis tools, allowing developers to understand and optimize their contracts' gas consumption. By analyzing gas usage, developers can identify functions or parts of the contract that require excessive gas and refine their code accordingly. This not only helps in reducing the operational costs associated with the contract, but also improves the overall efficiency and performance. So in competitive blockchain environment, optimizing for gas usage can significantly enhance the appeal and usability of smart contracts. Okay, now let's try to write a code, okay, and check the output. I will try to add this code and explain it, okay. Let's explain it line by line, then deploy it, compile it, and deploy and run this code. So at the first, to write the code, we should open a new file, okay, Select a new file and click on Solidity and choose the environment. Then write a smart contract in the code section, this one. Then we should click on the compile button, this one, okay, compile button, under the compiler window to compile the contract. Then we should, to execute the code, click on the deploy, this one, deploy button under deploy and run a transaction here. We will see it now. Okay. After deploying code, click on the methods here, calls under the drop down and deployed contracts. Let's يعني at the first explain the code, then we run it. Okay. The first line, as we said, is the version of a Pragma. So here is about the contract. Yes, is a compiler directive that specifies this one, that specifies the version of Solidity the contract is written in. In this case, it indicates that the contract is compatible with Solidity version 0.6.12. Okay. Then we have here the contract keyword used to define a new contract called what Solidity test. Okay. Inside this contract, there are 3 UNT here, A, B, and some. 3 UNT variables, A, B, and some. UNT represents an unsigned integer, and the initial values of A and B are set to 10 and 12, as you see, respectively, okay? The get result here, get result function is defined with the public visibility keyword, this one, public visibility keyword, that doesn't accept any arguments and returns integer value, okay? Inside this function, the variable sum is assigned to the value of A and B, which is 10 plus what 12. Then some value is returned by get result. This is return sum, means the value of sum is returned by get result function. So this contract is a simple example that demonstrates how to define variables, perform calculations, and return result in Solidity. When this contract is deployed and the get result function is called, it will calculate the sum of A and B, which is 22, and return the result. So let's now compile our code as the first step after writing the code, like this, compile. Okay, we have here, so we don't have any error here, and we got this sign about the correct code. Then we choose deploy. We get this line. After that, we should what? We should, after deploying the code, we should click on the method calls, this one here, and the method calls, like this. Okay, under the drop down of the deployed contracts to run the program. And for the output, click on the drop down on the console. We get result. Then we go here and we can see the output here. Decoded output is 22, which is 10. The sum of variable A and B is 22. So this is the output here. Now for debugging, click on the debug. This one. Sorry. Here we click on the debug. Okay. button corresponding to the method call. And in the console here, you can check each function call and variables assigned. Here we have solidity state A 10, B 12, and the sum at the first 0. Then after, and this is the stack. And we can see also the output here. So we can see the check the function call and variable assignment. This is the variable assignments, and this is the output of the this function of calling this function. Okay. So this is a brief overview of Solidity and how to execute Solidity smart contract. I hope you found this introduction helpful. Thank you.